most of what the problem is asking for, then hopefully I can get partial credit, because I
Yeah,
didn't have time to go through everything and get everything completely right. So I was
right.
kind of like, it's better to get at least everything done and
Yeah,
mostly
it's
right
fine.
than like only get half done and have them completely right. So I was worried that wouldn't bode well for me, but then it did.
Yeah. Well, it sounds like you did the right thing then. You took the right approach to it. All right. Well, let's start working on this, and hopefully this next test will be even better. So it says determine whether or not the function is continuous at the given values. Okay, so for it to be continuous basically just means that it's equal from the coming from the left and coming from the right. Did they change this, or did you?
Um, I changed it. It's like it was something from my textbook that she wanted us to have the signs the other way for.
Oh, she asked you to do this?
Yeah.
Okay. So basically what we have is this is a rational function left of 0. It's a rational function with a slant asymptote, right? Because the degree of the
Mm-hmm.
top is 1 more than the degree of the bottom. So there's some sort of slant asymptote for the left of 0. At 0, it equals 2. And then to the right of 0, it equals this exponential function. And they say determine whether or not the function is continuous at, I'm assuming they mean at the value of 0.
Yeah.
At the given value, at the value, oh, there it is, at c equals 0. All right, so in order for it to be, the only way it would be continuous is if when I plug in this one, I get 2. And when I plug into this one, I also get 2, because 2 is the value,
Mm-hmm.
right? So for it to
Yeah.
be continuous there, all of those would have to be equal to each other. So let's just plug it in here. What is 2 times e to the 0?
2.
It's 2. So that worked. Check. And what is 2 cubed plus 2 times 2 squared all over 2 squared? That looks like that's 2 times 2 cubed all over 2 squared, which means that cancels out with 2 of those, but I still have that equals what?
2.
4, not 2.
Oh, 4.
That equals 4, right? Because I had 4. If I did that right, I had 4 in the top. I had
Oh,
8
gotcha.
plus 8 is 16. 16 over 4 is 4. So no. And the reason is because here it didn't equal the same thing that it equaled here and here. So that means at some point, as you were approaching 0, this graph looked like it was up here at 4, and then it jumped down to 2, and then
Mm-hmm.
it continued. That makes sense?
So
Can you visualize?
yeah,
Okay.
we also have like statements for them. So like, how would you write out a statement for this? Because we kind of have to write out statements in terms of limits for whether it's continuous or not.
So you would say the limit as x approaches 0 from the left of f of x equals 4, but the limit as x approaches 0 from the right of f of x is 2. And f of 2 f of 0 equals 2. You kind of have to have all 3 of those parts there. You really don't have to have all 3 to prove that it's not continuous. You'd have to have all 3 of those parts to prove it's continuous. So you actually don't even need to say this, but you can say this and this, therefore, 3 dots like that is therefore the limit as x approaches 0 of f of x does not exist, and f of x is not continuous at x equals 0. What is the verbiage that they want you to use to prove continuity? Do they want you to prove that there is a limit and the limit is equal to the function value?
Yeah, so for ours, we had like the 3 steps to prove the limits, and that's that the limit must exist, the function value must exist, and that they must be equal.
Correct. So what you could say here is, since the limit does not exist, that's really all you need to say. The limit does not exist because it is not the same. I don't know how you have to say it, but I think what I've said is probably sufficient. No, you're saying the left-handed limit is 4, the right-hand limit is 1, therefore the limit does not exist. And since that's true, then f of x is not continuous. So you, like I said, you probably don't even need to say this. In fact, we can probably just erase that. I think that maybe confuses the issue so much. Does that make sense?
Yeah.
Does that seem like something that you've seen in your class?
Yeah.
Good. Next question says, consider this function. What 2 limits must be equal in order for f of x to be continuous at x equals -1? Do you know the answer to that?
No.
So
is it just
like
the limit coming from the left and the right?
Yep. It's what 2 limits? It's the left-handed and the right-handed limit. So it's the limit as x goes to -1 from the left of f of x, and the limit as x goes to -1 from the right of f of x. Those are the 2 limits that must be equal to each other. Not only that, what 2 limits must equal in order for f of x to be continuous? Well, and you would have to say furthermore, the wording of that is a little messy, isn't it? What 2 limits must equal? So maybe we should say it like this. That has to equal that, has to equal, specifically, it has to equal 2. The limit from the left at -1 and the limit from the right. So this one and this one have to be equal to each other, and they also have to be equal to the function value, which happens to be 2, right? So they have to equal 2. Got it? That makes sense?
Yep.
And then, so the same thing for letter B, the limit as x goes to 3 from the left of f of x must be equal to the limit as x goes to 3 from the right of f of x. And those specifically have to equal the function value. So I'll just even write f of 3. In fact, let me write that. They have to equal f of the function, which in this case equals 2, and in this case it equals -2. Does that make sense? So the left-handed limit and the right-handed limit and the function value itself all have to be the same. So it says determine what m and k must be equal to in order for the function to be continuous everywhere. So basically what we want this top thing, we want mx plus k to equal 2 when x is -1, right? So let's just plug that in and solve it. negative m plus k equals 2. Hold on a second. This is tricky because we're going to have to figure out what the k is as well. So I think we're going to have to set up an equation, a system of equations here. Let's start over. So we know that negative 1 times m plus whatever k is has to equal 2. And we know that, so that's for the top one. And for the bottom one, we know that they have to equal -2. Sorry, what is that? Let's see. Sorry, I'm trying to read this thing, trying to figure it out on the fly here. K mx plus k. No, start over. I don't think I did that right. Okay, let me start over. Let's do it this way. We know that f of -1 has to equal 2, right? And we know that f of 3 has to equal -2. So let's write those two equations out. So my equation is y equals mx plus k. And I'm going to plug in -1 and 2. There we go. I'm going to plug in these. I have a system of equations. Here's my blue one. I'll do this in blue. So when y is 2, negative m plus k, because x is -1, right? And when y is -2, 3, I plug 3 in for x, so 3m plus k. So solve this system of equations. So let's multiply this top by, or the bottom one, let's multiply this by -1. You understand why?
Yeah.
2 equals -3m minus k. And now let's add them together. Ignore this because that's gone. So it's 4 equals -4m. So what does m equal?
-1.
-1. And then plug that back into either one of those to solve for k. So 2 equals, plugging into the blue one, -1 plus k. So k equals what, 1?
Yeah.
K equals 1. So the values of m and k are -1 and 1 for it to be continuous everywhere. Got it?
Yep.
So we had two equations. We solved it with the system of equations. Next question says, find the limit as x approaches c of the average rate of change of each function.
Yeah, this was how it was written in our textbook.
Yeah, I'm trying to process this.
Yeah, I don't know. They worded it really weirdly.
So find the limit of the average rate of change of each function from c to x as x approaches c. So as x approaches 2, find the limit as x approaches 2, the limit of the average rate of change of each function. So what's do you have the equation for the average rate of change?
This is all that was given. Yeah.
Average rate of change. I believe there is a, you don't see anything like that?
I don't
Type
think.
in average rate of change of a function. It's your slope. It's f of x, or f of b minus f of a all over b minus a. That seems familiar to you?
I think so.
So let me see if I can, there's other ways to do this. Let me see if I can find another. Yeah, okay, so find the limit as x approaches to c of the average. So they want the limit as x approaches 2 of the average rate of change of the function
Mm-hmm.
from c to x. So for f of x minus f of c, that's what that means, all
Mhm.
over x minus c. That's what they want. Does that make sense? That's what they want you to find. So now let's plug it in. So this is the limit as x goes to 2 of f of x, which is 5x minus 3, minus f of c. Well, c is what?
2.
2. So 5 times 2 is 10, minus 3 is 7, all over x minus 2. So that equals the limit as x goes to 2 of 5x minus 10 all over x minus 2. And of course, this factors into the limit as x goes to 2 of 5 times x minus 2 all over x minus 2. So the x minus 2's cancel. And you just get the limit as x goes to 2 of 5, which just equals 5. And that is the correct answer. Questions about how I did that?
Can you briefly go through that one more time?
Sure. The reason I know it's the right answer, by the way, is because what's the derivative of this? Have you learned derivative yet?
I have not.
Oh, I'm so sorry. I was assuming that you had done derivatives and you haven't yet. So I know the derivative of this is 5. But yeah, that's right. I'm thinking you're in calculus. This is honors pre-calculus. My bad. So you're before you're learning that stuff, but basically what you're doing is you're taking this equation. Let me give you a visual for what you're doing. Your graph is this. The graph of this line is -3, and then the slope is 5, right? So it's this line right here, right? And you're trying to find the average rate of change between two parts on this graph. Well, what's the always in a line? What's always the average rate of change for a line? Does it matter where you start and where you finish?
No.
No, the average rate of change is always just going to be the slope, right? Which is 5. The average rate of change, I could have started here and ended here. It doesn't matter where I started and ended. The average rate of change is always going to be 5. Okay.
Yeah.
So they wanted you to do this algebraically, though, and the average rate of change, they wanted you to find the limit as x approaches c of the average rate of change. The average rate of change is your slope function, right? It's your change in y over your change in x. So what I did is I took the limit as x goes to 2 of the f of x minus f of 2, because this is my y1 and this is my y2, over my x1 minus my x2. Notice that I'm using the general equation for the first. I'm using just x and f of x, but I'm using a specific number to 2 and f of 2. And when I simplify it, not surprisingly, these things cancel out and I'm just left with a 5. That's always going to happen. You could have started with 3, f of 3 and 3. Wouldn't have mattered. Your average rate of change is always going to be 5 because this is a line and linear equations. That's always how it works. Now, if it was a quadratic, it wouldn't be quite so simple. If it was a quadratic equation, the average rate of change depends on where you're starting and where you're finishing. You understand what I'm saying? If you have a parabola like this, if you're going from here to here, the average rate of change is the slope of that line. If you're going from here to here, the average rate of change is the slope of that line. Do you understand?
Yeah.
In fact, do you have one similar to that, or do you want me to do one similar to help you see what I'm talking about?
I don't know if we're there yet, because this is just something that was like assigned as textbook homework, but we haven't really covered it in class.
Well, let's pretend like it said the exact same thing, but C was 2 and f of x was something else. Let's say that C was 2 and f of x was x squared plus 1. So the average rate of change, the limit as x goes to 2 of, again, it's f of x minus f of 2 all over x minus 2. So that means the limit as x goes to 2 of x squared plus 1 minus, what's f of 2 going to be?
5.
Good. All over x minus 2. This equals, this is not magic. I know it's going to seem like it, but trust me, it's not magic. It's math. See what happens?
Yeah.
This factors into what? X plus 2 and x minus 2.
Mm-hmm.
What happens here?
The x minus 2 cancels out.
So that's just the limit as x goes to 2 of x plus 2, which is just what?
4.
4. Now, what if I had called C 3? Let's do that one. And watch what happens. The limit as x goes to 3 of f of x minus f of 3 all over x minus 3. You're going to have x squared plus 1 minus what now?
10.
10 all over x minus 3, which factors into what?
X plus 3, x minus 3 over x minus 3.
Yep. X plus 3 times x minus 3 all over x minus 3. Those cancel. You get the limit as x goes to 3 of x plus 3, which equals
6.
6. You know why it's 6? Here's why. Because if you graph this limit right here, this limit is as it goes from, the limit as x gets closer and closer to 2. Here's 2 right here. 1, 2. 2 is right there. The tangent line, it's basically the tangent line. It's the slope of the tangent line is 4. But if I go to 3, if I go to the x value of 3, look how much farther up I'm on my graph. And what's the tangent line going to be? It's going to be steeper. See what I'm talking about?
Yeah.
Make that a little bit clearer. Not go so far. Let's say 2 is right here. This is the tangent line at 2. And this is the tangent line at 3. That's what you're finding here. You're finding the limit as x approaches 2 of that. You're basically finding the slope of the tangent line at those points. That's what a derivative is. It's turning a graph into a line. It's making the graph, you're looking at the instantaneous rate of change at any point on the graph, which is essentially the slope of the tangent line at that point. Because the tangent line is what measures the rate of change as you get closer and closer and closer to it. So hopefully that made sense, but if it didn't, it's okay. You'll learn it again later. Should we move on?
Yeah.
Okay. Did that confuse you, or do you kind of understand what I was talking about?
I think I kind of get it.
So I know I kind of said it fast, but I keep forgetting you're not in calculus yet. So that's a base. What I just showed you is kind of the basics of calculus of derivatives. Okay, find the numbers at which f is continuous. At which numbers is it discontinuous? So number one, this first one is everything, right?
Mm-hmm.
It's continuous everywhere. The first one. So it's continuous from in negative infinity to infinity. 2 tangent of x. Well, the tangent of x graph, if you think of basically, what are you not allowed to take the tangent of? Tangent, remember, tangent is sine over what?
I don't remember off the top of my head.
It's sine over cosine. So basically, what's the only thing you can't plug in here?
Is it 0?
It's where the cosine equals 0, right? Because you can't divide by 0. So where does the cosine equal 0? Well, the cosine is remember how in the trig or your unit circle, the cosine is your x coordinate. Remember that on your unit
Not
circle?
really.
Okay. So basically your cosine, the unit circle, which is my favorite thing in all of mathematics, is a huge cheat sheet, basically.
Mm-hmm.
So this angle right here, this unit circle is because that is 1 unit long. The radius is 1 unit of that circle.
Mm-hmm.
So your x coordinate is going to be your adjacent, right? And your y coordinate is going to be your opposite. Do you understand what I'm saying?
Yeah.
So your x is your adjacent and your y is your opposite. Well, what is the hypotenuse is just what for all of these?
1.
It's 1. So do you remember what a cosine is? The cosine of an angle is equal to the adjacent.
Is it the adjacent over the hypotenuse?
That's right. And if the hypotenuse is 1, then your cosine is just your adjacent. So this is basically your cosine, and this is your sine of that angle. So your unit circle is basically a big old cheat sheet, and it shows you all of your sines and your cosines. So if you remember your unit circle, this was √3/2, and this is 1/2 for a 30-degree angle.
Mm-hmm.
And this is a 60-degree angle, and it's just flipped. It's 1/2 √3/2, right? Etc. all the way around. Well, even better, these points right here, the points on the axes, this is 1, 0, this is 0, 1, this is -1, 0, and this is 0, -1. And what did I say? Where does the cosine equal 0? Well, which one's your cosine, your x or your y coordinate? Do you remember?
No.
The x is your cosine, and the y is your sine. I'm starting to think that maybe when you were doing this unit circle stuff, you were in COVID protocol, and you maybe didn't go over it as thoroughly as you should have.
Yeah,
Possibly.
we did like unit circle last year. I remember that I was supposed to do it, but I never really saw anything that we had to do with it. And then this year, our teacher just told us to like memorize it for our prerequisite test. And then I had it memorized for that. And then it never ended up being used in the class.
Well, you're using it now, because that's exactly what this is. we're dealing with unit circle. This is the unit circle. What I'm basically telling you is the tangent to find this right here, you recognize, oh, the tangent is sine over cosine, and you're not allowed to divide by 0. So where is the cosine equal to 0? Wherever the cosine equals 0, that's going to be a vertical asymptote. And that's going to be not a discontinuity. So where does the cosine equal 0? Think of your unit circle. It equals 0 there and there. So it's at pi over 2 or 90 degrees, and it's at 3 pi over 2. So that's the answer. Pi over 2 or negative pi over 2 or 3 pi over 2. Basically, where is this discontinuous? It's discontinuous at anywhere where x equals pi over 2 times k. Let's see, no. Pi over 2 plus pi over 2k. That's how you would write it, where k is an integer. No, that's not true. No, pi over 2 plus pi. My bad. Pi over 2 plus pi k. Yeah, pi over 2 plus pi k. I feel like I'm confusing you. That distance there is pi. That distance there is pi. This distance here on my unit circle, that distance there is pi. That distance there is pi. So basically as you go around your unit circle, every pi units starting at pi over 2, going forward or backward. Going forward, you're going to get at a cosine equals 0. Going backward, pi over 2, you're going to get a cosine equals 0. And then every pi degrees or 180 degrees, you're going to get to it again. You follow what I'm saying? Going around, boom, 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 boom. So that's the answer. At what numbers is F discontinuous? It's discontinuous for pi plus pi k, where k is an element of integers. That's your answer for that one. Kind of a tricky question because it requires you to go back and understand trig. I have a feeling we're going to have to do a lot of work with trig. And that's okay. I will tell you this is about, you will love the unit circle once you learn it the right way, which I'm guessing maybe you don't really know it. You don't get the value of it. The unit circle is your best friend. It is your best friend because it helps you understand trigonometry better than really anything else. And trigonometry is a big part of all the stuff that we do here. Anyway, shall I move on?
Yeah.
Okay. I can't really read your face. I'm not sure if you're like totally lost or whatever because I can't see you. So I'm just going to move on. So this is negative 3x cubed plus 7. What am I not allowed to plug in for this? Or where is it discontinuous? Is it ever discontinuous? If it's just a cubic?
No.
This is basically just moved up 7, right? And flipped sideways and stretched. So it's something like this. And is that ever going to be discontinuous?
No.
No, never. So no discontinuity. Now this one is going to be discontinuous because this is going to be x plus 2 and x minus 2 all over x plus 3 and x minus 3, right? So where is this discontinuous?
3 and negative 3.
That's right. So at x equals 3 and at x equals negative 3, it's discontinuous because you can't divide by 0. Right? For the same reason, remember I did this cosine thing up here? That's the same reason I rewrote tangent as sine over cosine, because I know wherever cosine equals 0 is where it's going to be a vertical, where it's going to have a vertical asymptote because you can't divide by 0. And that's why I did that. That's why I went back to my unit circle and I asked myself, when is the cosine of x equals 0? And I remembered, oh yeah, it's everywhere. It's at pi over 2, at 3 pi over 2, and every pi going forward and backward from there. Because cosines are cyclical functions. So this one, going back to this, you're going to have a vertical asymptote here and here, and your graph is going to be like this. Your tangent graph looks like this. That's what your tangent graph is doing. And so it's discontinuous at all of these points, at all these places. Good?
Yeah.
All right. Did we get to all of your questions?
Most of them.
All right, let's finish this one. Find the one-sided limit. Well, that one-sided limit is just going to be when you plug in 1, there's no problem. It's not discontinuous. So literally just plug in 1 and there's your answer. Because for that problem, there's no issue. If you can plug in a number, just plug it in. If it's continuous there, it doesn't matter if it's a right-handed limit or a left-handed limit. Okay. Same with this one.
Yeah.
Can I plug in pi over 2? What's the sign of pi over 2? Let's go back to my unit circle. Here's pi over 2. The sign is, remember, it's the sign is your y coordinate. It's your opposite. The sign is just 1. So that's your answer, 1. Now for this one, am I allowed to plug in -1 for this one?
No.
I'm not allowed to plug it in because it gives me 0 over 0. So instead of plugging in -1, I'm going to factor and cancel because I know that I'll be able to do that. Now, do you remember the SOAP rule? Same.
I do not.
Opposite, always positive. So here it is. A cubed minus or plus b cubed factors into this. It's always like this. It's the same sign, the opposite sign, and always positive sign. It's called the SOAP rule. And then you take your whatever's being cubed, you put it here and here. You multiply it here in the middle. You multiply them and you square them on the outsides. That's how you factor a difference or sum of perfect cubes. So for this, it's the same sign, which is a negative in this case, the opposite sign, which is a positive in this case, and always positive, and it's still these same letters. So this would be x and 1, x squared, 1x, and 1 squared. These cancel, boom, boom. Now I can plug -1 in, and I'll get -2 over 1. No, 2. Is that right? 3. What do I get? I did it too fast. Here, let me plug it in. -1 squared minus a -1 plus a 1. So this is 1 plus 1 plus 1. Yep, that's 3. So it's -2 over 3. -2/3 is your answer. Okay.
Yep.
But that's a whole, right? That actually doesn't work. What is the function value? The function value of that is undefined because you're not allowed to plug it in. You have a removable discontinuity. But the whole would be at 2/3. It would be at -1, 2/3. All right. I don't know that we have time for this, but what time do we start?
We started at like 5:40.
5:40. Okay. Well, I'll do this. I'll just real quick talk you through it. Okay. So what's the domain of F? Everything, but I'm doing a scan from left to right. And I'm asking
Looks
where
like
does it?
everything but 4.
Everything but -6. No, 4 and -4 is included because it's here.
I said +4.
Correct. So everything but -6 and +4. Yep. What's the range? Scan it. That now, even though there's a hole there, look at how this one goes down forever. So that is not excluded. -4 is not excluded. In fact, none of the range is all real numbers. I can tell you that right away, because I can see that this is going down forever and this is going up forever. So when I'm scanning, I'm always going to touch a part of the graph. Even though there's holes in certain places, the range, there's a whole bunch of places that it could be touching. So the range is all real numbers. Find the x-intercepts if there are any. So there's one here at -8. There's one at, it looks like maybe -5. There's one at maybe -3. And there's none at 4 because there's an open hole there.
Mhm.
So those 3. The y-intercepts, if any, there's only going to be one. It looks like maybe at 3. Right?
Yeah.
So again, that would be 0, 3. And all of these would be negative, like that would be like that, right?
Mhm.
Find f of 8, -8. F of -8 is 0. F of -4, so f of -8 is 0.
Mhm.
F of -4 is 2. Find f of 2 and 6. F of 2 is 3. It's not this, right? Don't
Mhm.
look at the empty hole. And f of 6 is 2 as well. The limit as x goes to -6 is -infinity. From the left, I'm sorry. From the left is positive infinity. From the right is -infinity. Do you see that?
Yeah.
The limit as x goes to -4 from the left and the right. From the left is, you would expect it to be 2, and from the right, you would expect it to be -2. Does the limit as x goes to 4, positive 4 exist? Yes. Because for positive 4, you would expect it to be 0. But it's not. Is f continuous at -6? No. Is it continuous at 0? Yes. Is it continuous at 4? No, because there's a hole. Find the limit as x goes to -4 from the right. Didn't I already do that? I feel like I already did that. Oh, I did -2 from the right. My bad. -4 from the right is -2. 51 was asking about limit as x goes to 2 from the right and the left. From the left, it's 1. From the right, it's -4. Does the limit as x goes to 0 exist? Yes. It's 3. Is f continuous at -4? No. Is it continuous at 2? No. Is it continuous at 5? Yes. You get that? There's that
Yep.
5. It's continuous there. It's not continuous at the other one. So there's all your answers. All right. Whoops.
Yep.
Hopefully that was helpful. Let's see.
Yeah, it was.
All right. I'm today I did this entirely from my new iPad that I just got, testing it out. So let's see if I can, I don't know where I can find how I turn on and off my Zoom. There it is. All right. So I'm stopping the live stream.